Given a matrix of n by n elements, so m rows and n columns, return all elements of the matrix in clockwise spiral order. Hi everyone, we're here today for another Exponent mock interview with Greg. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. Okay, thank you so much for being here with us today, Greg. Could you quickly introduce yourself to our viewers?
Yeah, thanks for inviting me. I'm one of the interviewers here at Exponent while also simultaneously working at Pinterest.
Great, yeah, and you can schedule coaching sessions with Greg. All right, so let's get right into our question. The question today is, given a matrix of n by n elements, so m rows and n columns, return all elements of the matrix in clockwise spiral order. And if you want an example, we have like a coder pad set up with the input and output example.
To get started, I think I'm going to use the drawing feature that CoderPad has to offer. It's one of the amazing features that allows me to explain what I'm trying to do when I enter these kind of coding interviews, right? So the point of the problem is to solve the spiral matrix. So effectively, I'm traversing a matrix from going right, down, left, and up until I've really traversed the entirety of a matrix. So one of the ways that I like to approach this problem is by using state machines. The idea is when I'm in a state, I'm persisting that same action. So for that top section, I persist the action of going right. For that down action, I'm persisting the action of going down. For the left action, I'm persisting the action of left. And going up, I persist the action of going up. And because I persist these actions, these are typically what will become my states. My states will be right, down, left, and up. And not only that, but I will intermingle in between these states. I will circulate this state machine up until I've completed my entirety of my matrix from start to finish. Now, of course, I don't want to start out in one of these states. I want to have some kind of initializing state. So I would initialize my variables, whatever those state variables might be, and then I'll go into processing. So some of the things to keep track of while I'm processing is, at what point do I turn from right to down? At what time do I turn down to left? At what time do I turn left to up? And then at what point do I go up back to right? And the last thing to keep track of is, at what point do I leave this system? So one of the things is that I want to keep track is, at what point do I reach this left or this rightmost element? So in essence, I have some concept of a max column. In the same way, I have some idea of a max row. That same idea can happen on the lowermost points as well. So I have a min column and a min row. And as I traverse this matrix, I actually change these variables. And so these will be exactly how I update my program. Okay. So I'll go out through the process of actually translating this state machine into a program.
Okay, great. Yeah, so to recap then, you're using each of these states to determine which matrix entries to print out next, right? And then you're determining when to transition from one state to another based off of the, like, whether or not we've reached like the max or min row or column, right?
That's right.
Okay, great.
So one of the things that I'm first going to start out with is I'm going to immediately modularize. So what I want to do is be able to take a matrix and call this function called spiral matrix. And then what I can do is I can actually take this matrix A, which you thankfully gave, and call this function. Def spiral matrix A. And what I'm going to do is I'm going to print A. This way I can test that my code actually works. Oh, I included that def keyword. Looks like it's working. That's a great time for me to start programming. So let's see. What do I want to do? I want to return an array. So if I'm transforming a two-dimensional array into a one-dimensional array, it might be useful for me to keep track of that spiral order inside a list. At the beginning, I also said I wanted to keep track of 4 major variables: that max column, that max row, that min column, and that min row. Now specifically, how do I get these values? Well, when I reach the column, in order to grab the column number, that's going to be in the first row of that two-dimensional matrix, minus 1. With the max row, since the matrix is already stored in row order first, all I have to do is call the length of that list, minus 1. For that min column, all I'm going to do is set it up at that first element, and at min row, I'm also going to set it up at that first element. Next, what I'm going to do is I'm going to call my states. I'll have 4 states. I have state right, I have state left, I have state down, and I have state up. The only issue with Python is there is no way to enumerate these states in a nice and convenient way without using or referencing Python 3.10. So I have to simply go through the process of enumerating these states as simple integers. That's totally fine by me. Last but not least, I want to initialize certain variables. I want to say, what part of the matrix am I starting in? Since I want to start in this 1 place, so it starts at 1 and spirals out, that's going to be the matrix entry 0, 0. I also want to make sure that I start out in the right state. So if I take a look at my drawing pad, it looks like I go from that initialized state until I reach the right state. So I'm going to start in current state equals state right. Now, when it comes to state machines, typically what people do is they run them within a while loop. And since I don't know really what that ending condition is, all I'm going to say is 1 equals 1. But there might be a better end condition for me later on. And then I have to write my code. So when it comes to converting a state machine, all I have to do is just ask myself, what state am I currently in? So that's easy. That's just a long if statement, because unfortunately, Python does not have a switch statement currently available until 3.10. So what I can ask is, if first state is in the state right, else if cur state is in the state left, else if cur state is in state down. And last but not least, I could use an else statement, or I could use an elif. I'm going to choose to use an elif just to be specific. That state right is going to be up. And these are going to be my 4 states. And now I have to understand, what am I doing in each of those states? So specifically, if I'm going to the right, That means I'm incrementing one of my values. It's either my I values or my j values. So the way a matrix is stored, it starts out with the value 0, 0. And for each increment up, it increments 0, 1 on the left-hand side, or it increments 1, 0 on the right-hand side. The first column is typically referred to as the row, and the second element is typically referred to as the column index. So from this, I'm going to update first the column index. So to make sure I'm doing that right, I'm checking that if j, which is my column index, is less than the max column. So if j is less than the max column, what do I want to do? Well, all I want to do is add that element into my spiral order matrix. Makes sense.
Mm-hmm.
So now what happens otherwise? Well, else I want, and then what I want to do is once I added that element, I'm going to go right. And going right in computer talk is going to be adding 1 to j.
Mm-hmm.
Otherwise, what happens when I reach that final end? So back to my diagram, what happens when I reach this rightmost place? Well, that is when j equals the max column. So if that's true, then what I'm going to do is, if once j reaches that max column, then I'm going to change my state to go down. And I'm going to also update what rows I can enter. In this case, since I've completed that first row, I've completed the entirety of this first row, I no longer ever go back to it. And so I'm going to update that first row. So min row gets updated. And I keep running this while loop. Also, one of the most beautiful inventions since the dawn of computers is the ability to copy and paste. And that's what I'm going to do for the rest of these logic statements. So now that I've copied and pasted this code into the next block, I'm going to edit my logic. In the second block, which is the down block, instead of updating my column index, now I'm going to update my row index. So that means that I need to update my i's. I also need my i's to be less than the maximum row. Once I've reached the end of this, the end of all my rows, then I'm going to change my state. This time, I'm going to go from down to left. I'm also going to update a major element. Specifically, now since I've entered this portion, I'm no longer ever going to re-enter the same column. Since it's the max column, I'm going to update my maximum column. And this time, I'm going to subtract it by 1. I'm going to copy code again. Now that I'm in my down state, I'm going to check that j, which is my column index, is greater than my min column. And I'll keep adding and adding until I can't add anymore. And this time, in order to go down, I'm going to, or in order to go, let's see, in order to go left, I'm going to change my column index, and I'm going to decrement by 1 each time.
Mm-hmm.
Now, what happens when I finally reach my minimum column? That's when I'm going to change my states one more time. I'm going to change from left to up. So my next state will be state up. And I'll also update my max row, since that's the row I just traversed, by 1. Last but not least, I'm going to copy my code one more time. If, in this case, I'm decrementing I, which is decrementing the current row that I'm in. So I want to make sure that I is greater than min row. I want to add those elements to my spiral order. And then I want to decrement my I since I'm going up in my matrix. I also want to make sure that my state, my current state, once I reach the end, will go right once again. And last but not least, my min column, which is the column I just traversed, gets incremented by 1. Well, this looks pretty good. Now I just need a way to end or terminate this while loop. The good thing is that I know how many elements I'm supposed to traverse. I know the number of elements because I keep track of them in my spiral order variable. So I'm going to make sure that the length of my spiral order is less than the total number of terms. But how many terms are there? To start off with, I know that there's going to be exactly the length of the matrix times the width of the matrix, which is exactly max column plus 1 times max row plus 1. And that should work.
Yeah, this logic makes a lot of sense to me. Would you want to maybe test the code on some test cases?
Yeah, let's print that first test case that you gave me.
Great.
I get a none. Oh, it's because I didn't return my spiral order. The good news is that as I'm running my code, I'm telling you exactly what's being added or what I expect my output should be. So you wouldn't think that I'm spamming the compiler or anything like that. So it looks like I get 1, 2, 3, 2, 1, 2, 3, 2, 1. In order to debug this, how about I add some print statements?
Yeah, that sounds like a good idea. So you can see each update as it happens.
Yeah. So as I add elements, I'm going to add the print statement spiral order. I'm also going to add the ij elements to my print statement so I can see what's going on under the hood.
Yeah, so line 66, you're decrementing the column. Is that what is supposed to happen?
I think so, right? I'm going down.
I thought then we're supposed to increment the row.
Right. Line 66, I'm in state down.
Mm-hmm.
So if I'm going down, then I should be decrementing. Oh, let's see. I think you're right. I was off. Well, let's see if I put this
Yeah,
right.
because next we want to end up at like row 1, column 2, right?
Oh, I see what I did. I swapped the two states. Okay. Wait, did I swap those two states? Let's see. Right, down, left, up. Right, down, left. Oh yeah, I typed it in wrong. This is supposed to be right, down, left, up.
Yeah.
And I literally write right state down. Okay.
Yeah, there you go.
Okay. So what I'm going to do is persist what I have. I'm going to add the states, and that way I can see it. Okay. So next I'm going to add the states to my print statements so that I know what's going on with my i's and my j's. So it looks like I go from 0 to 2, which is the same as going from right to down. And then I go back to right again. Oh, I think I see it. I've swapped these two states.
Mhm.
So it was supposed to be, this is what's going down, and this is what's going left.
Right.
Oops.
Yeah, you want to increment the row instead when you're going down, right? Instead of decrementing the column.
That's right. You're totally right. Yep. So if I run it, now it looks like it's doing what it should be doing.
Yeah.
I can go right, down, left, up. So it should go 1, 2, 3, 6, 9, 8, 7, 4, 5. That
Yeah.
looks like it is. So I'm
Mhm.
going to remove my print statements and run it one last time. Cool. So I'm done, right?
Would you want to test your code on any other test cases, or does this look okay to you?
Oh, are there more test cases?
Yeah, I can give you a couple of other ones. Let's see.
So I'm going to go ahead and copy these two cases into runnable code. Okay, let's try this first case, B. Looks like it runs just fine, and it should go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks good to me. And now I'm going to run the second matrix. I get all of the elements.
Yeah, and not, is that correct?
I don't think it's correct.
15, 16.
It goes from 19 to 12.
Yeah, so it should be going from 19 to 20, right?
That's right. Actually, what I was supposed to do was an infinite loop, but anyway. Code, right?
Yeah, so what do you think happened here?
I don't know. What I'm going to do is I'm going to add some print statements back to my code to see what's happening.
Okay, great.
Specifically, I'm going to see what states are changing. So I'm going to print the current element as well as the state that I'm in. And that way I know exactly what's going on at each turn of my matrix.
Mhm.
So if I were to draw it, there's 0 and it goes 1, 2, 3, 4. Oh, then it goes down to 4. 5, 6, 7. It goes right to 8,
Mhm.
9, 10, up 11, 12, 13, 14, 15, 16, 17, 18, 19, and then it has an issue with going up.
Mhm.
Because if we see, 1 should take us into the 3 position. So we're not having the right state change.
Yeah, so maybe there's something to do with your logic for determining when left should switch into the up state.
That makes sense. maybe it happens when I change from min col to max column. So let's take a look at max column min row, max row, min column, and min row. I'm also going to take a look, instead of at the actual element, I'm going to look at I and J.
You might need that check everywhere where the column, min column, max column are checked, right?
Let's
That's
see.
not the only state where you check that.
Right, I know I checked min column and max column in these two blocks.
Yep, yeah. So let's try that also.
And I guess I'll try it for the J's as well. Min row, min column. So it appears that I start to reach these issues of maxing out my indices
Right, yeah, and
at that 18th element.
it ends up not moving at all, right?
Right. Oh, it might be something as simple as if this last state is editing the max row, I should be editing the min column.
Mm-hmm.
Oh, I got closer. At least now it's 19.
Yeah, can you see any other issues with those extra if cases that you added?
Yeah, they might be adding too many elements. Let's see, let's start with the first one. That looks like it worked.
Great, yeah. So can you explain a little bit about like what the issue here was?
The first one was I was accidentally updating the wrong element,
Right, yeah.
which I'm surprised that worked, but it did. The other thing though, it could have been because min column and min row might be symmetric. Maybe that's why it worked. The other case might be that when I'm in the up state, so specifically this one, when I try to traverse back into that right state, what happens is I could be traversing into elements exceeding. So in this case, J would exceed the max column.
Mhm.
And all of the rest of these elements might also exceed their max states. So I need to account for that. I don't know how many to account for, so that's why I ran the first one. But it
Mhm.
seems to work. So let's see. Let's see if it still works for all the other test cases. If I rerun, oh, I wonder if I messed up.
Um, yeah, I think you accidentally deleted a line that you might have needed.
I did delete a line, you're right.
Yeah, there you go.
Maybe I shouldn't delete lines in the future. That seemed to work. I can also get rid of these print statements.
Yeah, great.
So it still works for C. Does it work for A? One, two, three, six, nine, 8, 7, 4, 5. Still works for A.
Yep, perfect.
And then let's see if it works for B. It looks like it works for B.
Yes. Great. Okay. Any other last edge cases that you'd want to check?
None that I can see.
Mhm. Well, sometimes it's always good to check like for example, like a single element matrix or like an empty matrix, right?
Oh, sure. Let's try that. it prints out the one element matrix. Should I
Perfect.
test with matrices that don't follow this convention that you told me? Because in the prompt it says I'll always be guaranteed an m row and column matrix. Because
Right.
it,
M could possibly be 0, maybe, right?
sure. Looks like I have an error.
Oh, I meant like, what if you had, like it was just empty like that?
Oh, let's see. Well, it looks like it still works if it's empty.
Great. Yeah, perfect. All right, so I think this is a great place to pause. That was a fantastic job. Thank you for showing us your technique for working through this entire problem. So I'd love to hear your take on how this interview went. What do you think went well, and what do you think you would want to change?
Sure. Things I want to change and things I want that went well. I thought the drawing pad and drawing my thoughts went well. That was very useful. I thought it was a great way to kind of explain what's going on, and I could refer back to it too. So as
Yeah.
I was coding, I didn't have to just memorize everything I was updating. I could just go look at my drawing and see what was going on, and you could
Yeah.
see very clearly what I was trying to do
Mhm.
as I was speaking out.
Mhm.
Things that could have gone better. I mean, I wish I had a more impressive debugger than just print statements, but here we are. We have print statements, and that's totally fine.
Mhm.
Um, I think what would have been nice is if I had maybe a better way to explicate these states. Mm.
Yeah, that makes sense. That was actually one of my thoughts too, is that part of the reason why this code was so difficult to debug was because there's like such a large chunk of code that had like many different like intricate if else statements. And so maybe it would have helped to modularize each of the actions for each of the states. So you can have one function that's like move left or move right, move up, and move down, right? And that breaks up the code into smaller, more modular functions.
Oh, that would have been useful as well.
Yeah.
You could
Um,
have add spaces. That would have maybe made it more readable as well.
yeah. And for those modular functions, if you're worried about having to pass in all of these different variables, it might have helped to have something like a struct or a named tuple, which Python has to store all of the state information. So that would include like I, J, the current state, and the current min call and max call, min row, and max call row, right?
Oh, that's true. I totally forgot about that.
Yeah, and then so then when it came to printing out the debug information as well, you only have to print out that one like struct or name tuple, rather than having to type it all out. Yeah. Mhm.
Something to keep in mind in the future.
Yeah, but I had many other thoughts too on like all of the things that you did do well. I totally agree. Like, I really like that you had such a clear explanation of the algorithm before you dived into the code, and the diagram too really helped me understand what you planned on doing. And I like that you continue to refer back to it as you were coding, so you were explaining each line of code, and so it was really easy for me to follow along, which is really important in an interview. And it also showed that you did a very careful job of making sure that you understood the question well, which is also important. Um, I also really like this solution. I think that using a state machine is a really clever and straightforward way to abstract away all of the different details when it comes to trying to solve this problem. Um, yeah, and you also showed some great debugging skills. You tried to like isolate the location of the bug by doing different debug statements. And so that was really awesome too. And I didn't really need to help you that much with debugging. Um, yeah, and then so aside from just modularizing the code a little bit more, I would say one extra thing that would have made this interview even better is just making sure that you test an extensive number of test cases, because also demonstrating your testing abilities is also an important part of demonstrating your software engineering skills in an interview.
Oh,
Yeah.
absolutely.
So how does that all sound?
Oh, that sounds lovely to me. Thank you so much for your help.
And thank you for coming today and like teaching us about state machines and showing us how you would approach this problem. Mhm. So thanks everybody for watching, and good luck on your upcoming interviews. Bye everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.